I think we are on the hour, actually 1 minute
Yes.
past the hour, so we can kick things off. We do have, well, we had a few attendees already before the hour hit, but we have a few more now. Hello and welcome everybody who has joined in today for this session on JSON in Postgres. We're joined today with Jashanpreet Singh. Thank you, Jashan, for joining us and being willing to share your expertise and your experience on JSON with us today. Just a little brief intro. My name is Umair Shahid. I am the founder of Stormatics, and we are focused on providing Postgres solutions for the enterprise. Jashanpreet Singh is a full stack developer whose roots started off with MongoDB when he started working with unstructured data. And he's here to tell us why he switched to Postgres later on in his professional career. Again, welcome and thank you for joining us, Jashan. So, interesting anecdote I know that you shared with me some time back, and that is how you ended up being called Jason instead of Jashan. Yeah. Perhaps we can start off by sharing with the audience how that came into being.
Yeah. Hi, Umair. Thanks for the introduction. So yeah, my name is Jashanpreet Singh, but at my workplace, I was being called Jason Singh because throughout the day, I would just be talking about JSON this, JSON that. We have to update the format of the JSON. JSON structure is not correct, or the API will return JSON, and you need to have a JSON config here. And every time, people would hear, like, I'm always talking about JSON, right? So people started calling me Jason. And that's how I got my name. And I thought, it's a cool thing. I just kept it like that. Yeah.
Good for you. Good for you. So JSON, of course, it gained, the JSON format gained a massive amount of popularity over the past decade, I believe. And that is the claim to fame for MongoDB as well. So, in your opinion, in your experience, why do you think that format, that structure is so, well, let me revisit that word. I shouldn't call it structure probably, just that format for unstructured data. Why is that so popular?
So back when I was doing my bachelor's in college, and we were reading about systems and how to design and how to basically pass around data, we would mostly work with XML at that moment. In my professional career, since I've started working, I have not worked with XML. Ever since I've stepped into my career, it has always been a JSON format. And the reason I believe is that when you look at JSON, it's very human readable. It's very intuitive to understand a JSON data right while looking at it, right? So, and a lot of, even with the popularity of JavaScript itself, moving from front end to back end, also, I think made it a little bit popular, like the whole JSON structure, and just working with JSON was much easier than like your traditional structured data, and just the format and how intuitive it was, I think just made it a really popular choice for data representation throughout.
Got it. And I guess it's that ease of use and that intuitive nature of the format that perhaps made MongoDB that popular as well. So maybe tell us a little bit about how you started off with MongoDB as you stepped into your professional life.
Yeah, so when I graduated, I was looking to start my career in web development. At that point, the hot trending or the trending thing or the hot thing was the MERN stack, which the MERN was basically Mongo, Express, React, and Node.js, right? And there was also a meme stack where you just replace React with Angular. So I thought I'll pick up the MERN stack because that was the most popular thing, and I wanted to learn everything related to that, right? So and that there was basically how I was introduced to the concept of full stack development and how data flows between databases, APIs, and front end, and all the concepts. And throughout that, it was like the data itself that you're dealing with, whether it was on front end, whether it was on back end, or whether it was on the database level, you're dealing with something very similar to JSON throughout, right? So even when you start writing your queries on the API layer, when you're fetching the data or when you're doing some manipulation, you're just writing something very similar to what you would write in like a regular JSON parsing, right? So in that sense, I think the whole popularity around it, or how like why people like why this MERN stack also picked up popularity, and why I was also gravitated towards it, because it was just much easier to understand that data in all that same format, which was just JSON. Right? So JSON stands for JavaScript object notation, but it has long, uh, it has long far out of JavaScript now. Everywhere we see JSON, and it's like beyond the JavaScript world now. But I think that is where its roots were, and that is how I got introduced to the MongoDB, because I wanted to learn this full stack, and this thing was like this. The web development was most like Mongo was the most popular database option out there.
Got it. So why do you think that is? I mean, you think JSON and you say Mongo, and I'm not saying you as in you, but that's the typical perception out there. When somebody mentions JSON, the solution tends to be Mongo. Why do you think that is?
Because Mongo, I think, just made the whole non-structured data popular. Like it was existed there before. And even when you go talk about, I want to store my JSON data in a database, right? The first answer that will come up to you will be the MongoDB itself. So, I mean, it created this very perception that, when you talk about non-structure, or when you talk about JSON data, you're talking about Mongo itself. Like there wasn't even like people wouldn't even speak about other options in the first place. Talk about non-structured data, you talk about JSON, and you talk about JSON, you talk about MongoDB itself. Right? And every content, like piece of content out there, will tell you that MongoDB is your choice. You just at some point you stop, you just look at all the solutions out there, and yeah, like MongoDB is the thing.
Got it. So you of course made a transition to Postgres at some point. And I'm assuming that there was some point preceding that where you were researching for alternatives. So my question then becomes, what was the trigger point when you started searching for alternatives to Mongo to handle your JSON data?
So it will be very use case specific itself. So we were getting a lot of data from the IoT sensors, right? And
Okay.
usually when you talk about data from IoT sensors, you talk about an unstructured data. I mean, that is just what people like think about when you're talking about IoT sensors. And so we were storing all of that data in the JSON format, because that is what we were getting from the API from where we were pulling that data from, right? So it made sense to store the same data, use that data in the API layer, send that to the front end, create the graphs, right? The problem with that data was there was a temporal component, and data would sometimes be missing from like maybe one data is missing, two data points are missing, or some data would be missing in between those points. And so it made sense to interpolate the data, the missing values, with a certain logic, with a certain mathematic logic, which the use case itself was fine. So initially we were doing it at the API layer, right? And that was very compute intensive. Like we were computing so many values at the same time, and it was turning out to be very difficult. And then we thought of storing that data in the database itself after computing the values, but that would mean corrupting our original data, right? So we were actually, so I was actually looking at things that could handle time series data better, in terms of these some temporal functions and everything. That's how I stumbled upon something called timescale DB, which was a Postgres extension. And that is how I got to know about this Postgres. Obviously, I had studied SQL in my bachelor's, but I never really professionally used it before. And then that's how I started learning about the whole Postgres ecosystem, how everything fits in together. And once there was initial learning, there's an initial I think mind shift when you're going from non-structured data to structured, and like you have to write these queries and everything. But after that initial learning curve, when I got to learn about this whole Postgres ecosystem and how like you can extend its functionality and how it performs really well with like some specific data, it was like that's when I never looked back at the MongoDB itself. Like, okay, Postgres can handle everything that you throw at it, right? And yeah, and I never looked back since then. So it's been more than 4 years, and I don't think I've gone back to MongoDB except in some use cases where it was very particular that you use MongoDB for certain cases. Yeah,
got it. But Mongo being the specialized database for unstructured data, and especially for JSON data, there's bound to be some performance hit when you move to Postgres. And have you felt that? Have you experienced that?
So actually, it turned out to be better in Postgres because we were also like we wanted to do like when we started importing the data, we also realized that there were a lot of joins that we're doing at the application layer that could now be done at the database layer, right? And we also realized like storing, of course, like when you're talking about moving from non-structured data to your structured like Postgres and everything, you're not going it like, okay, all like I'm storing all the data in the JSON column itself. Like I flattened out some of the fields that I knew were always going to be there, like talking about IoT. Temporal, like the dimension is always, time dimension is always going to be there. So that's my one column. And there are a few other columns that I knew are going to be there in the table. So I flattened them, obviously, like stored it in a key and like columns, right? Which actually led to us exploring opportunities to like work better with the data in terms of indexing that data. Actually, we could index other columns and we could also do joins, which also I think made the data slightly more extendable to the whole extent when we were working with that data. But yeah, it was like a little bit of learning curve moving from that NoSQL to SQL.
Got it. So essentially what you're saying is that if you just compare the database to the database, that you might feel that there's a performance hit. But if you look at the entire application stack and the stuff that you can do within the database when you move to Postgres, the entire application stack actually starts to perform better.
Yeah, because I think when you're talking about structured data, it does make you think of certain, like it actually makes you think about database engineering, right? While JSON gives a lot of flexibility, technically that gives you a lot of freedom to work with the data. But when you do too much nesting, no matter which database you're talking about, nesting is always going to be a performance overhead, even while parsing the data itself, right? I mean, if your JSON is like 7 levels deep, just looking at your code, no matter whether you're looking at SQL query, whether you're looking at SQL or no SQL query, it's going to be a little difficult to understand that, right? But when you're working with structured data, it pushes you to think about your data in a way that you better understand it, and even like think about architecting the application. While JSON is like when you talk about JSON in MongoDB, it's just a free world. You can do everything you want. Everything is just as open as it.
Got it. So the other claim to fame for Mongo is also its ability to scale horizontally. Moving to Postgres, I mean, Postgres is a database that was designed initially to scale vertically. The horizontal scaling almost does not exist. Right? Have you encountered that issue, or have you encountered a bottleneck like that?
Not in my own journey, but in terms of like I haven't faced that issue where my writes are slower, that I need to look at alternate options to think about a data from a database perspective. But in essence, I have built a managed database cluster where there are multiple read replicas, which is like when we talk about horizontal scaling, right? There are multiple read replicas, and there is one read write instance, and that is only being used for the write, and then the replication instances are used for all the reading values, right? And MongoDB certainly is like with the, as you said, replication built in, will like out of the box will perform better in those scenarios, like rather than comparing to a single Postgres instance. But in all the applications I have worked so far, with like scaling up to like many GBs of data, I have not seen it as such. It totally depends on how you architect the application. And by the time like this bottleneck came of like by the time that this bottleneck came of where I needed like separate instances, like a single node of database could not handle the data itself, we had done like all the optimization that we could think of in terms of indexing the data, in terms of creating views, continuous aggregates, and like lot many things and everything. So that really helped. We're already done a lot of data engineering, and I think that was a final step, was basically creating this read replicas and that. But yeah, out of the box, I would say MongoDB supports like better replication. But you can obviously build a very, very scalable system with Postgres also.
Right. We also have a comment from our audience, Dennis Magda. I hope I'm pronouncing your name correctly. Please forgive me if I'm not. Very correctly points out technologies like Citus and Yugabyte that are designed to scale horizontally. And again, Citus is an extension. Yugabyte calls itself biocompatible with Postgres. And if you if you do an out of the box Postgres engine, that's slightly different. So, but yes, Dennis, you're right. There definitely is an ecosystem out there that helps overcome some of the shortcomings. Maybe a harsh word to use here, but it does. This ecosystem does enhance the functionality of Postgres. And I think that ecosystem is something that you wanted to touch on, Jashan. But before we get on to that, there was an interesting comment you made when we were discussing some of these points earlier in the day today about the correlation between the popularity of Postgres around the time when JSON functionality or the native JSON functionality was introduced in it. So perhaps, share your insight with the audience over here as well.
Yeah, so JSON as a data type was introduced in Postgres in 2012. And when it was introduced, the popularity of just Postgres just shot up. It's just like, if you look at it, it's a linear curve, right? And finally in 2019, when JSON standard of the SQL itself was introduced, right? So JSON became a first-class citizen in the Postgres world itself, right? So, I mean, there are obviously, when you talk about SQL itself, right, the structured data itself, right, it's kind of hard to basically put all of the data in a structured format because you're not completely sure how the application is going to change. And everybody was also like wanted that JSON functionality, like what that trend shows you that people wanted like a JSON functionality in the database itself. And when it was introduced, like Postgres popularity was shot up, right? But even then, even though like JSON is now supported completely in Postgres to a huge extent to whatever your needs may be, I still believe the perception is still the same, that JSON is equal to MongoDB. But JSON is a first-class citizen in Postgres. So don't think of it as any like lesser maintained, like an outcast in the structural world. It's now heavily, like, it's completely supported all the SQL JSON standard, right? And you can,
I think that I completely agree. I think that the functionality of being able to handle unstructured data within Postgres is underrated, understated, and underestimated. It needs to be talked about a lot more than it currently is. And it really helps in OLAP kind of operations and data analytics, being able to handle the structured data. So, coming to the point of the ecosystem, I know that you alluded to it a little while back, and the Postgres ecosystem definitely is something that the community is very proud of and maintains very diligently. So, maybe share with us why you feel, from the perspective of being a full stack developer, that the ecosystem is important and the ability to handle different forms of data is important.
Yeah. So like going back to that initial development procedure as a full stack developer, where I'm handling the front end development and the back end development and the database development also, MongoDB was like an obvious choice because at that point, because I think the front end, like at that time, I'm also doing a lot of learning, right? I'm changing the structure of the data that is happening at the front end level, at the back end level. Like at that moment, when you're starting out the web development, you're thinking more from the front end perspective, right? As you grow along, you realize that the real challenges lies in managing the data itself, which I think which is much more well done in the Postgres ecosystem, I believe, right? And like working with like the Postgres ecosystem. So initially I told you about like how temporal data was managed by Timescale DB, even though Postgres itself has a lot of functionality around temporal data, honestly, right? You might not even need Timescale DB depending on your use case. But the real thing was PostGIS extension. It's one of the most popular extension regarding Postgres. And my background, since I am working with a lot of geospatial data, right? So PostGIS came in really handy while working with GIS data itself, right? So even in PostGIS, there was something that I hit the limit with, which was like, so I had a lot of geospatial data and I want to index it with a certain grid of data. So it's just like you have a lot of bigger shapes and you want to divide it into small shapes, so you can look at certain, like you can divide it into smaller shapes, so it's easier to query and you can do some analytics on it. So there is this library that Uber developed, which is called, I'm a little digressing here, but just to explain how vast the this ecosystem is. So Uber developed a library called H3, which was basically dividing a shape into hexagons. And I was able to find a Postgres binding to it, right? So initially, when I stumbled upon that library, I thought I'll have to do all of this in the application layer. This is gonna be a lot of back and forth with, pulling the data from the database, then doing something query on it, and then putting it back. Like this is gonna be a pain. But it had a Postgres binding, which amazed me because, there was, it's like you find something and you can like find a Postgres like link to it. That's what I realized at that moment. And even with like even when you hit the limits with Postgres, there are these other options as well, like Citus data, Yugabyte is something, right, that you can look at. So in itself, Postgres ecosystem is so vast that it can handle a lot of use cases. I would say like majority of the use cases. And when you do hit a limit, you will find something that is built around that limit, like how Yugabyte is built for, for some things that limits Postgres itself.
Right. And I think that, there's another angle to this as well. The term that I tend to use when talking about Postgres and this same functionality, or the ability to handle different sorts of data and different use cases, is that, it's a hyper-converged database. Now, the term hyper-converged is typically used in networking hardware, but I think that it can be used for the case of Postgres as well, because of the variety of use cases that it can handle pretty efficiently at that as well.
Yeah.
And the other aspect of it is from a completely operational perspective, from a completely DevOps perspective. If there is one technology that you're using in-house for your enterprise data support, there's one technology that you need to keep up to date. There is one technology that you need to worry about, patching and hardening. There is only one technology that you need to develop skills for, that you need to develop processes for. So one playbook that captures everything in your entire organization. Now compare that with trying to maintain 4 different database technologies getting security patches for the 4 different technologies, getting playbooks for 4 different technologies, and trying to make sure that you're staying on top of them all the time. There's a significant reduction of operational overhead sticking to a single hyperconverged database. So it was 2012 when JSON functionality was introduced, and I think that in the first go it was JSON, and in the next release it was JSON-B. It was, it almost felt like an afterthought, and somebody thought, hey, we should probably have a binary format of JSON in here. But maybe share the difference between JSON and JSON-B, and what are the different use cases for the two.
Yeah, so the JSON and the JSON-B, like JSON-B is just binary, like it's a JSON that you store it in a binary format, right? At the Postgres, like how it supports both JSON and JSON-B. So JSON is just storing the JSON as it is without like doing anything to it. It will also preserve the white spaces, order of keys in the JSON object. While working with JSON-B, it will store it in an optimized binary format, where you can do a lot more with JSON data, like talking about the binary format. You can index it, you can query specific keys, and again, like it will parse the JSON and then like store it in an optimized binary format, which will also like not preserve your order of the keys and not do any, like remove all the white spaces, and also will delete duplicate keys if they're there. Like ideally, you can build a JSON with duplicate keys, but whenever you parse it, it will delete those duplicate keys, right? So if I would say like the common use cases, if you're just putting the JSON and just taking it out without doing any operations on it, then JSON makes more sense. But if you want to do, like if you want to query if you want to do some filters, or if you want to like query it a certain way and everything, then JSON-B makes more sense. But JSON-B also has an overhead of additional storage. JSON-B will take more space on your database. So that is something that you also might want to consider while working with the JSON data in your database.
Got it. Now, in terms of the licensing, I know that the community prides itself on being very liberal when it comes to the license for such usage. That may also be the reason why there are so many variations of Postgres out there, fully managed, serverless. The example that we have seen, already in the chat, is Citus and Yugabyte. You've also mentioned a few of them. In your opinion, does the license play a role in the popularity, in the diversity?
I think it does. If you look at the Postgres ecosystem, every developer who's contributing to the Postgres ecosystem can see all the 40 years of development that has gone, almost 40 years of development that has gone into the Postgres, right? And that also, like, as you said, like it also gives rise to so many flavors of Postgres that are out there. So if you're choosing a technology, and previously, like you said, it becomes like your single repository for all your data needs. So that is what I was also converging to. So even like edge cases like rasters, which is something very like edge case in the satellite world and everything, they are supported in the Postgres, and something you can manage in the Postgres. So if you're choosing a technology, you don't want it to be going like that, it being taken away from you in the future. I mean, you want to be like, okay, this is an open source technology I trust. This is being backed by an amazing community. And if you don't want to think about, or ideally shouldn't be worried about licensing issues in the future, right? Whichever cloud you're in, however you are using that technology, it's like it should be completely up to you. And the whole when it comes to licensing issues, like that's always an important factor when choosing a certain technology.
Sure, of course. Now, in terms of another comment that you had made was what you were calling semi-structured data, or handling semi-structured data, taking the middle road between structured and unstructured. So maybe elaborate on that a little bit.
Yeah, so I mean, in software technology, when anybody comes to or anybody comes to it, is this the best choice? Like, what is the best technology to do this, or what is the best framework to do this? The answer will always be it depends. I mean, it's just like every I think to every other question we always say it depends. It's just has become like a common two words in the software engineering world. When working with data, uh, structured and unstructured are basically two ends of the spectrum of data that you'll be dealing with. I believe like the data will always not be fully structured, right? But it will also not always be fully unstructured. Usually it will be somewhere in the middle. You would be sure of some of the data that you know, okay, this is going to be there. If you are dealing with users, then they will definitely have an ID or they will definitely have an email. Like you're sure about that, right? But some of the things that you might want to expand on in the future or that you want, like that is not in your control. They might be happening. So that is the unstructured part of it, right? You look at any data, you can think of what is the structured part and what is the unstructured part. So I think like in most of the cases, you will be working with something a semi-structured data. And I believe like Postgres give you the best of the both worlds, where if you're working with structured data, it gives you all the all the best capabilities like a database can give while working with structured data. And it also really has a very good support for the unstructured data itself. Right? And yeah, I mean, and thinking about structured data, like it has a lot of merits. And again, the demerit is it's not flexible. But with no structured data, it also leads like if you have a lot of unstructured data also like in your database, then you're also dealing with a lot of mess, because some fields are missing and some like data inconsistency problems are there in your database. So I guess it just works like the semi-structured world is something that is a real world scenario. Structured, completely unstructured is an ideal scenario, and unstructured is something that you would like want to have. Like I want unlimited flexibility and everything, but again, it's something in the middle that gives you the best performance. Is what I believe. Is what I have realized working as a developer from the developer side.
Got it. Got it. I digress, but as I was taking a sip from this bottle, I realized it's timescale.
Yeah.
So let's talk about the native handling or the native functions that are available within Postgres to handle and manipulate JSON data. I understand that you're getting new features and new functions with every major release that comes out, but any kind of functionality that you feel is missing or you wish that Postgres had for you to be able to handle JSON data better?
I mean, right now with JSON data in Postgres, you can pretty much do anything. You can filter certain elements. You can have like really go the nesting level or like deep nesting level to find certain queries. You can also index your JSON data based with GIN, B-tree indexes and hashes, depending on your use case. Like if you're primarily care about comparing the values of the data, then you would use something like B-tree. And again, even in JSON indexing, you can also index a certain key inside the JSON. So it's not like you have to index the entire JSON itself. And even like even something like GIN trigrams is also supported while working with JSON data itself, like JSON B data. So when I'm referring to indexing in JSON, it's always JSON B, right? And yeah. And in terms of, I think in terms of missing or performance issues with like JSON is when you reach a certain level where the JSON is too big and the Postgres itself has to store it in separate chunks, which is called toasting of the data. It has to compress and store it in separate chunks until it stores it in a default page size of the Postgres itself, which is I think 2K, right? So when you reach that level, you are working with the toasted data, right? And when you're querying that data or when you're doing any operation with that data, you have to collect the entire chunks, take it back to give it to the users to work on it. So that is something that is, I think, still a little bit of an issue in terms of performance while working with JSON. Even something that if you're updating a single key inside JSON, so it will update the whole thing. So that is something that still needs to be like resolved in the Postgres domain. And the other more, I would say, less talked about, and you have also said ki, like how it's underrated. I think we need more content in terms of blogs, videos, and posts on how JSON is used in Postgres and how it can be used, because it will then motivate the community to do more performance and or actually figure out where they're facing the bottleneck in the whole JSON in Postgres system, right? Because right now I know like a lot of people are using it, but they still think of it, okay, it's something like maybe a very quirky feature in Postgres. Oh, it supports JSON, that's nice. But maybe if it's used a little bit more, and if there are much more content out there regarding the whole JSON thing, then I would think we would see some real feedback on how it can be improved. In personally, whatever I have used JSON in Postgres for, I have never faced like a bottleneck issue so far in like working with JSON, whether it's like querying the JSON or indexing or like performance queries and everything. So far, I've not. And there are even so another thing is like there are a lot of functions by which you can convert JSON data. You can convert a normal structured data with JSON data as well, like aggregate, object aggregate, create JSON objects. So that's also like something that I've found very useful, to be honest, because there was this use case of creating. So there is also something called GeoJSON, which is like geometrical representation, GeoJSON. So it's like it's how you can represent a shape in a JSON format. So with JSON aggregate object or JSON object, you can technically create that JSON from a structured data itself. You can query, like for example, you can query all the points in a table and then create like a multi-point geometry from the JSON object. So I think in that, whatever I could think of in terms of how I want to use the JSON in database, I have found a use case for it. But again, like the toasting thing and like updating a single key inside a JSON, that is something that I think will require some work. And based on some feedback that we get from the community and how like that, which will motivate the contributors to actually put more thought into it. And even I'm reading this Postgres internals book now,
Okay.
so that I can understand how this thing works internally. Like that's how I understood about this whole toasting concept, which
Got it.
is again invisible to the developer, right? Because it's something which is very happening at the very core layer of the database. So even I'm trying to understand how, is there something that I can contribute to this ecosystem in terms of feedback or something that we can do with the whole JSON support in Postgres.
Right. So just for your information, we have Postgres 16 coming out in the September-October timeframe. And one of the interesting features around JSON is the SQL JSON construct that's coming up. So, if you haven't seen that already, take a look at the release notes and take a look. You can probably get your hands dirty. The beta release is already out, so you can start playing around with it if you want to. But good point about content. I hope that this session right here will motivate a few people to write about it or talk about it. And this could be the initiation of creating more content around JSON and the JSON functionality. Last 5 minutes on the clock that we have, and I wanted to ask this question that we got from the audience anyways, and that is, what advice would you give to somebody who is moving from Mongo to Postgres for a variety of reasons? Could be a variety of reasons, but what are the gotchas? What are the pitfalls? What are the benefits? How can someone convince their boss to make the move?
So when I shifted from MongoDB to Postgres, like there is something that you have to do, a mental shift of work, like looking at data, right? With Mongo, you're always looking at the JSON format, and it's a flexible format. You can put any key value there at any point. But that also makes that if there are 3 developers working with the same API layer, then somebody might decide that this should be an array, and other person might decide that it should be an object. Just a random example, right? But you have to think of this mental shift of working from non-structured data to structured data, that you have to define certain parameters when you're working with the data itself. You obviously do that in the Mongo world when you're working with the JSON data in MongoDB. You still do it, but this SQL, the structured world, makes you think more hard on the same aspects, right? And it's the gotchas are this only. Like you have to think like your data is now. You have to think hard about how you want to structure this data, right? Which actually leads to some great performance benefits and actually might lead to a better specification of your application, whatever you're building, right? In terms of, I would say like whatever are your most common fields that you know are always going to be there in your JSON data, make them represent as columns in structured data, right? Because they're always going to be there and you will get a huge performance benefit from it. Like ideally you can put all of your data in a single JSON column, but I would not advise this because again, it will be like a huge storage overhead. Also, you'll be duplicating the keys and values each time you're storing that value, right? It might be easier to work with an ORM first, because again, you're used to using some sort of layer that talks to your database rather than writing like SQL queries. So ORMs help a lot because they help you think a certain way when talking about the data in terms of models and how the relations work. Yeah. So the another thing, moving from no structure to the structured world, when you talk about relations, so relations is something that you need to think about, like how my data is related to each other. Like no data, I think in this world exists in isolation where it's not connected to anything else. It is related to something, right? Users generate data, there is data connected to the users. So that is a little bit of mental shift that you also might have to do in terms of your data relating to some other data, right? Yeah, so all these considerations of moving from no structure to structured, like no SQL to structure, is something you can think of. And ideally, it helps your mental, like in terms of imaging, like how I want to write this application and how the database is gonna expand on the whole thing.
Right. And one of the things that I'm actually taking away from these comments, Jashan, is that as you make that move, it's important to think about the entire application stack, and you have the database do the job that it is supposed to do, and that the job that it is good at doing. Because if you move to that relational format and yet keep handling those relations at the application layer, there's no point.
There's no point. Yeah. Yeah. So ideally, when talking about like my initial understanding of the data, like I would see database as something where I just put data for persistent storage and nothing else. But obviously, database is much more than that, right? You have so many concepts when you talk about database, like asset, transactions, and like how you store the data, how you replicate it, take backups, and how you just move around the data. Another thing I missed while talking about the Postgres ecosystem is I was recently like ChatGPT has like ruffled up like so many feathers in the software industry, right? So if you have something like that you want to work with, like sort of LLMs, right? So Postgres also supports vector datasets, which is used to train LLMs. And I thought this is like, and I read it and I saw it. Yeah, it's Postgres. It can do that, right? I mean, it wasn't even shocking at that point. So if you are thinking that you have an application and your data, like it needs a database, you can think of Postgres, like, and you will find like some content over it, and it just really works in that.
Yeah, Jonathan Katz has actually written an article on how he thinks vectors are the new JSON for Postgres.
Yeah. Okay.
It's an interesting article, but yeah. So we're I think we are out of time, and well, we are done with all the questions that I had as well for this session. We'll open it up to the audience. If anybody has a question, please post it on the chat or the Q&A section. I'm sure that Justin will be happy to answer. As we wait for a question to come in, let me just take a moment to acknowledge the database, the document database community who has arranged this session and who is arranging other sessions on, unstructured data, document data, etc., and championing the cause there. And especially Maria Azizova, who is quiet and behind the scenes and not really, is showing up as document database community over here, but who has been moderating and has been the force behind this entire session. Thank you for arranging all of this. Okay, so we don't really have any questions coming in. I don't see any. Maria, could you confirm if you saw any questions come in on YouTube or LinkedIn?
No, Umer, we don't have any questions on YouTube and on LinkedIn.
Okay. So we do have a comment from Dennis saying that he'd like to share a quick story related to the question of moving from Mongo to Postgres. So yeah, sure, Dennis, please share with us. Please enlighten us.
Yeah, hello everyone. Thanks for this session. I want to tell you, the reason why I asked this question is I had a lunch with a friend of mine that was probably a month ago, and we were sitting, enjoying our food, and he was sharing his current technical challenge. The challenge was that he joined recently a very famous Wall Street company, and he owned a full stack application. So that full stack application was running on MongoDB. And his goal for the next couple of months was to move to the public cloud environment. And presently, that application in the MongoDB instance, you're running in their private data center. And he was thinking that would be like a quick move. And he went to their DevOps team, to the DBAs, asking, let's say, just folks, please provision for me a MongoDB instance in the public environment with the current configuration. And they just told him, hey man, hold on, not that fast. We do support Mongo, but only in the private data centers. If you want us to support Mongo in the public cloud environment, that we need to define some policies. We need to figure out how to, let's say, manage it, how to upgrade, etc., etc. And it can take a while. But just in case you know that we support two databases, you can switch to PostgreSQL. And then my friend sits and looks at me, says like, how can I switch, let's say, from Mongo to PostgreSQL? It's like two different types of databases. And I was just curious. I'm saying like, but like, why do you use Mongo? What's so brilliant about Mongo? He says, let's say that my application uses JSON as a data format. Like I store JSON as this in Mongo. I receive this JSON from, let's say, from the upstream applications and services, and I store this JSON in Mongo. Mongo comes with a convenient API to process this data, etc., etc. And I'm looking at him and saying, like, do you know that Postgres supports JSON as the first-class citizen? His eyes, just get just wide open, and he goes like, are you kidding me? No, like, and I would say that even more, Postgres comes with special operators that would simplify the search and processing of those JSONs. And even you can index any JSON field that you would like. And he kind of was sitting and scratching his head, and that was probably one of the best lunch times he had with me. So that was actually a long context for that question, because I just wanted to know like what to share, what should be my follow-up with my friend, like what he should learn if he wants to make a move from Mongo to Postgres, because he has some hurdles with his infrastructure team.
This is brilliant. Thank you so much for sharing this, Dennis. It's always refreshing to hear about a real world use case. We can talk theory, and but it's so much better when you talk about actual problems that people are trying to solve in the field. So thank you very much for sharing that. I would go as far as that. If that friend of yours does actually go ahead making the move from Mongo to Postgres, I'd encourage him to write about it, to write about the story and the journey, and share that journey with the world.
Yeah, absolutely.
I-
You know, like, and that friend knows Postgres pretty well, because we used to work together in the past at one of our first companies, and Postgres was our first database. Those days, Postgres was, let's say, looked like a geek the database for the geeks, but we still used it. But let's say, well, as you folks said, that Postgres JSON support was added, I don't know, like how many years ago? Like
2012.
after, yeah, like
almost more than 10 years now.
Exactly. But when we were building our first application on Postgres with my friend, at that time the database did not have that support. But like then, I learned about this JSON support a long time ago, because I happened to know Oleg Bartinov, who contributed this feature to the PostgreSQL engine.
Yeah.
But my friend, no, like he didn't know that, and that's actually the problem that you highlighted. A lot of developers, brilliant developers, who know even Postgres, there is not enough content that explains and describes, educates on those JSON capabilities that the database has. If they knew, then probably we would have had more developers who would be using Postgres for the unstructured data.
Yeah. One similar story that I would also like to share. So I was working with this company, and I looked at the database. They were using two databases for storing the data. One was basically a Postgres instance for storing all the data, and another one was MongoDB. And the only thing that they had stored in MongoDB was some sort of permission management for the user, where the permission management were like key value pairs, and it was just like, okay, if the user has this permission, so true, false, and a lot of true, false, and then nested values inside true, false. Like if they have permission to this module, and then submodule, and then submodule, and so on and so forth. And I just looked at it and I'm like, but why are you using MongoDB? Because they said like it's JSON. But I'm like, but you can do that in Postgres. Like you just can, like there is no point of maintaining these two separate databases just because you want to support JSON for a very small case. And you can do it. There was another thing that also I worked on where very similar use case was managing these user permissions, which will keep on changing. So there were like, let's say there were 100 different permissions working with a lot of modules and submodules and so on. And some user will have like very small subset, another user will have another small subset of permissions and so on and so forth, right? So again, like the JSON is supported, and you can index like certain permissions, like certain modules that you know that the user is going to be querying. So based on your input request, you can always filter whether this user has that permission or not. And JSON was really helpful because those permissions kept on expanding and shrinking as the application evolved, right? So yeah, just the use cases I wanted to share around how JSON was used in a structured world where the data itself was, everyone is happy with structured world, but they still wanted to have that JSON compatible capability. But some people just didn't even think, Postgres does support it, so you can do that. Yeah.
Yeah, it's a common story like that, and you're right. That's why we need to advocate more about this.
Yeah.
Okay, so I don't think that we are getting any more questions, but yeah, I guess we can wrap up a little early. We have 5 more minutes, but there are no more questions. But to the audience, in case something comes to mind later, there's always the document database community Slack channel. Maria had linked you to it in the chat. Feel free to interact over there. Feel free to reach out to me, to Justin, in case you want to on the Slack. And till then, take care of yourselves. Have a great day ahead. Thank you, Justin, again for joining us and sharing your insights and your experience.
Yeah, I would also thanks Umair for having me here. Thanks Maria. Thanks the whole document DB community. I'm glad to be part of this all, and I'm thankful for all the Postgres people, especially to Oleg, who contributed the initial JSON thing, JSON support and the Postgres, and everyone who came, who joined us. Thanks for having me here. See you in the future.
Great.
Thank you very much. Thank you both.
Bye.
I hope we will see you again.
I hope to see you too.
Bye-bye.
Bye.
Bye.
Bye.